Yep, gotta formalize. Okay, integrals. Net change as the integral of rate. Here's the theorem. It's theorem 1. And let me remind you of something. You remember what those are? Yeah. Sometimes you'll see them referred to in those different forms. Velocity is the derivative of position. Acceleration is the derivative of velocity, second derivative of position, right? This theorem refers to S prime, which is the velocity, correct? Right. Indeed, thank you for that. The net change in S of t, so the net change in a distance, for example, over an interval of time is given by the integral from time 1 to time 2 of the velocity function. Okay. Which we would write as the integral of velocity is position evaluated at time 1 minus, time 2 minus position at time 1. Okay, that's the integral of rate of change, and here is the net change. So no, because if you look at the way we defined it over here, it's little s of t. Position function is little s of t from S prime. Okay, so, all right. Let's do something here. So let's say water leaks from a tank at a rate of 2 plus 5t liters per hour. Where t is number of hours after 7 a.m. How much water is lost between 9 and 11 a.m. What hour is 9 a.m.? 2 and 4. So if this is our rate, the integral of rate okay, am I going crazy fast? I guess I'll slow down. Please don't. Is it racing? Oh, good. Are we caught up? Okay, so we'll follow the same theme here. The integral of the rate from 2 to 4, because we want 9 to 11. What's the integral there? Is that right? I know you can do the integrals. So there were a few of you on that quiz that had trouble with this part, notation. If you take the integral, you have to write evaluated from 2 to 4. No longer is the integral valid. The other part some of you had trouble with, you plug this one in first to both of them. Plug the 4 into both of them, minus the 2 in. Okay. It's not an uncommon mistake. And then if you do the math, if it's a multiple choice, then you have to make an answer. It's okay. 34 liters.
I'm thinking of like Game of War which would get up to 36.
Yeah.
I hate Game of War.
So here's where you have to be kind of careful. We got a negative number because we've lost fluid, right? Yeah. When you state if this is a free response, the tank lost how many?
34.
34. Yep.
It didn't lose negative.
No, it did not.
That would be gay.
Correct. So be careful there. In the interest of time, because we are almost out of time, turn to page 323, please. Yes. Are you given a function? No, you're just given some data in a table. Right. So which quantity is represented by this integral from T1 to T2 of Q of T?
Traffic flow rate. Cars per hour.
Okay, this is the flow rate. So what is that integral going to represent? Yep, total number of cars, net change, right? The total number of cars passed during the time interval, okay? So it's the integral of a rate, you get total. Part B, okay, the flow rate, not the number of cars that passed, it's the rate, is recorded here in 15-minute intervals. Estimate the number of cars using the highway. Okay, you just need to do a left or right-handed endpoint
And you can actually average the two if you want to get a good approximate answer. Okay. So you're just taking the total area, length times width of these rectangles. They're 0.25 hours wide, and then this is the flow rate of each 15-minute interval. Okay. We can't get an exact number because we don't have a function. Does that explain enough of it? Where are you stuck?
So on part A,
Part A,
yeah.
this Q of T is the rate at which cars are passing. If you take the integral of rate, you get total number of cars. So this represents the total cars that passed over the time interval. Okay. Yeah, we're going to finish tomorrow.
So we're gonna do the homework in class tomorrow, or?
Now, if
You just do Thursday?
Now then, listen.
part B, this is the actual data that comes along with the flow rate. Right. So an integral is, remember doing the sums where you just calculated the size of the rectangle, the area of the rectangles? That's the same thing here. So you basically have a 0.25 hour, 15 minutes out of 60, 0.25 wide, and if you're on the left-handed, you're 1044 tall. Right there, 0.25 and 1044. The next one is 0.25 times 1297. Okay, you're taking the area of each rectangle. And that gives you the total approximate number of cars. Okay. They did both the left and the right, so you can average it and get a more accurate total. Okay. Good. Here we go. We're going to have a few more examples tomorrow, but this will get you started. Here's A. B, and the spiraling.
Does that say 1 and 3?
No, it's a comma.
Oh.
There's that free response. This is going to be due on Thursday. Please try some tonight. We'll have more examples tomorrow.